In May 2025, satellites spotted a record 37.5 million tons of sargassum floating across the Atlantic, enough brown seaweed to ring the Caribbean with a scratchy, sulfur-scented necklace visible from space. The mats look harmless offshore, havens for tiny fish and baby turtles, but once they hit the beach, the chemistry flips. They rot, belch hydrogen sulfide, stain turquoise water the color of iced tea, and turn postcard economies into cleanup operations. This isn't a one-off bad season either. Since 2011, the so-called Great Atlantic Sargassum Belt has become an annual event, swelling and shrinking with winds, currents, and nutrient pulses like a living conveyor belt stretching from West Africa to the Gulf of Mexico. In June 2025, the belt was still enormous at roughly 33.5 million tons. USF's monthly bulletin called June a turning point, not because it was small, but because it might finally start declining from an unprecedented peak. Let's start with the damage. Tourism gets hammered first. Hotels hire armies of workers and backhoes to haul heaps of seaweed off the sand every morning, a Sisyphean ritual that costs serious money. The US EPA has tallied region-wide cleanup in a bad year at roughly $120 million. And that's just 2018. Since then, the belt has grown and seasons have intensified. In Mexico's Quintana Roo, estimates peg annual cleanup around $1.1 million per kilometer of beach when you factor in equipment disposal and the fact that you inadvertently remove sand with each scoop. When a season like 2025 hits, bookings sag. Some reports put peak season drops in the 30 to 40% range at the worst hit destinations. The public health side is subtler but real. Rotting sargassum releases hydrogen sulfide, that rotten egg smell, plus ammonia. Field measurements under beach piles often rise above nuisance levels, with occasional spikes over 100 parts per million right at the source. Dangerous for workers and anyone with asthma. The good news is that air levels drop fast as you move away, but safety guidelines are strict for a reason. U.S. workplace rules cap hydrogen sulfide around 10 parts per million, set a hard ceiling near 20 parts per million with only brief peaks up to 50 parts per million allowed. And public health guidance warns that even about 0.07 parts per million can be a concern for short-term exposure. If you're raking seaweed all day, those numbers matter. Ecologically, the beaching events can be brutal. Nearshore mats shade and smother seagrass and coral. Decomposition strips oxygen from the water and pushes pH down, triggering hypoxia that can lead to fish kills. Heavy strandings also trap nesting sea turtles and obstruct hatchlings while altering the temperature of nest sands. A 2025 review notes sargassum influxes depressing coastal pH from 8.7 to 8.9 down to the high 7s alongside elevated organic lows, exactly the conditions that stress reefs. This is the part tourists don't see, the chemistry shift after the Instagram photos. So why is this happening now? The short version, the ocean changed and we helped. In 2019, researchers identified the Great Atlantic Sargassum Belt and tied its formation to a cocktail of factors: currents, upwelling, dust and river nutrients, and a climate-driven regime shift around 2011. The Amazon and Orinoco are often cast as the villains delivering fertilizer-rich outflows to the tropical Atlantic, and there is evidence their pulses line up with bloom timing. But new work in 2025 argues that changes in ocean circulation and vertical mixing, bringing nutrients up from depth, are doing more of the heavy lifting than river runoff alone. In other words, it's not just Amazon fertilizer did it. It's a systemic ocean shift that sargassum is exploiting. Either way, the blooms are thriving on a planet warmer, dustier, and richer in nitrogen than it used to be. And that's the story that matters for what comes next. Here's the twist. The same biomass-choking beaches might be the raw material for a new coastal industry, if we solve the chemistry and logistics. Start with construction. In Quintana Roo, an entrepreneur gained fame turning sargassum into sarga block bricks and building homes with them, an act of circular judo that converts garbage into shelter. Meanwhile, researchers are road testing sargassum cement composites and ceramic aggregates. Early life cycle assessments in Mexico suggest that biomass-based concrete mixes, including seaweed additives, can cut building emissions across most states over a 50-year lifespan. Another team at the University of Washington went broader than sargassum and showed that adding seaweed powder to cement can drop global warming potential by approximately 21% while maintaining strength. Those aren't marketing claims, that's lab-grade embodied carbon math, and the construction sector needs every credible lever it can pull. If you're enjoying the video so far, don't forget to hit that like button. It really helps this kind of deep dive content reach more people. Energy is the other obvious play. Anaerobic digestion turns wet biomass into biogas. One Mexico-based engineer pegs output at roughly 20,000 cubic meters of biogas from 500 tons of sargassum, enough energy to matter for an island grid when paired with storage and co-feedstocks. Grenada and a handful of resorts have piloted digesters as proof of concept. Beyond biogas, macroalgae are prime candidates for hydrothermal liquefaction, a process that cooks wet biomass under pressure into biocrude that can be upgraded toward jet fuel range hydrocarbons. No drying required. And researchers are even extracting hydrogen directly from sargassum via catalytic thermochemical routes, reporting greater than 60 millimoles of H2 per gram of dry biomass in early studies. None of these are silver bullets and none are free. The pre-treatment chemistry is everything, but the physics works and the pilot lines are real. Textiles and plastics are a quieter revolution. Seaweed-derived polymers, think alginate and fucoidan, can replace petrochemical thickeners and coatings in packaging and cosmetics. Companies like Notpla have already shown seaweed films and coatings that home compost in weeks instead of centuries and don't shed microplastics. On fiber, kelp-based yarns like Keel Labs' Kelson aren't sargassum yet, but they demonstrate the material logic. No arable land, no irrigation, far less chemistry than cotton, and a cleaner end of life than polyester. Cotton's water footprint is famously intense, thousands of liters for a single t-shirt, while seaweed grows in saltwater on sunlight. If sargassum alginates can be wet spun into textiles or laminated into vegan leather-style composites, as labs are attempting, you can start swapping out the dirtiest parts of fashion supply chain with ocean regrown inputs. It's not magic, it's process engineering and LCA. Cosmetics and biopharma might be the sleeper hit. Fucoidan, a sulfated polysaccharide abundant in brown seaweeds including many sargassum species, has documented anti-inflammatory, antioxidant, and even anti-cancer activity in preclinical research, and it's already creeping into topical formulations. A Finnish group is now scaling fucoidan and alginate extraction specifically from invasive sargassum, with demo production underway and a first-of-a-kind biorefinery partnership announced for 2028. If they can standardize purity and molecular weight at cosmetic and pharma grade, the Caribbean could end up exporting actives instead of shipping wet waste to landfills. The hardest question isn't what can we make, it's how do we get the stuff before it rots. Governments and startups are racing to intercept mats offshore where sargassum is clean and buoyant. Mexico's Navy has deployed floating barriers and specialized sargassara boats along the Quintana Roo coast, while local marinas intercept hundreds of tons before landfall on busy weeks. In the Dominican Republic, teams are experimenting with literal collection modules and trawling rigs. Across the region, drone mapping and new satellite products are inching toward beach-level forecasts. The logic is simple: harvest offshore, you get higher value biomass. Miss the window, you get a sulfur bomb and a landfill bill. Now the fine print, the reasons this hasn't already become a perfect circular economy story. First, metals. Brown seaweeds are natural sponges for trace elements. Caribbean sargassum frequently carries arsenic, sometimes at tens of milligrams per kilogram, along with other metals depending on where it drifted. Left to decompose in place, that arsenic can leach. That complicates the sexy ideas. Animal feed, compost on crops, skin contact products, unless you remove or speciate it carefully. The good news: new hot water and citric acid washes have shown big drops in total arsenic in lab tests, but that has to be scaled, audited, and matched to strict end-use standards. Second, logistics and costs. Sargassum isn't consistent. A record year like 2025 floods the supply chain, a quiet year starves it. Building factories around an unpredictable input makes investors nervous unless you can combine sources, diversify products, or add storage. Third, policy. Much of the region is stuck paying for daily cleanup while underfunding the boring but crucial bits. Waste permits, staging sites, standardized testing, and regional procurement that would make offtake predictable. You can't bootstrap an industry when your biomass arrives as an emergency. There's movement though. Mexico and the Dominican Republic have floated a bilateral initiative to coordinate response and industry development. The EU has backed pilots in Grenada, which is exploring a full biogas facility, and private players are raising funds to farm or capture sargassum offshore to stabilize supply for bioplastics and fertilizer. Origin by Ocean is building a supply chain around sargassum-derived alginate and fucoidan. Carbon Wave is turning it into emulsifiers and exploring bio-based leather and films. These are not press release fantasies. They're early stabs at industrial muscle. The bet is straightforward. If you can upgrade sargassum into energy, materials, and cosmetic actives at scale, the beaches get cleaner, coastal economies diversify, and you reduce a slice of demand for fossil-derived inputs. Zoom out, and sargassum looks less like a fluke and more like a climate-era indicator species. It thrives on disturbance, warmer seas, altered currents, nutrient spikes, and it threads together issues we usually keep in separate drawers. Deforestation in the Amazon, fertilizer use in the Midwest, shipping lanes and dust plumes, reef decline, and coastal real estate. You can either treat it as a seasonal curse or, as some island states are trying, treat it as a raw material you're foolish to leave on the beach. The trick is to keep the science honest. We shouldn't sell seaweed saves the planet snake oil. But it's equally misguided to assume the only future for sargassum is dump trucks and despair. The next decade will come down to 3 unlocks. First, chemistry that makes contaminated, inconsistent biomass safe and valuable, especially arsenic removal and salt management that pass stringent standards. Second, smart infrastructure. Offshore interception, staging, drying, and regional labs that turn beach emergencies into industrial feedstock. Third, policy and finance, pooled procurement across islands, concessional capital for first-of-a-kind plants, and clean, transparent rules about where to put the mountains that still arrive. If those locks turn, the seaweed that once symbolized disaster could fuel the Caribbean's future economy, but only if innovation keeps pace with the tide. All the sources I used to make this video are linked in the description. If you'd like to see a video on how scientists are growing the next plastic using mushrooms, I also dropped the link down below. Thanks for watching.